This lesson introduces the idea of a proportion and the skill called solving a proportion. I'm going to start with the following question. How do you know if two fractions are equal? Sometimes it is somewhat obvious. For example, if you were going to look at 7 over 20 and 11 over 20, it should be pretty obvious that they're not equal because we've got 7/20ths and here we've got more 20ths. We've got 11/20ths. In fact, you could say that 7/20ths is less than 11/20ths. And hopefully that's something you're familiar with. Here's where it becomes a little trickier. Suppose you had the following two fractions, 17 out of 20 and 45 out of 50. To make this a real example, suppose these were two test scores that students had received. One student got a 17 out of 20 on an exam, another student got a 45 out of 50, and they wanted to know how their scores compared. Well, there's a couple of ways you could figure out if they're equal or which one is larger. One would be to convert them to decimals. So if you either by hand or on your calculator, if you were to divide 17 by 20, you'd convert 17 over 20 to a decimal and you would get 0.85. On the other hand, if you were to do 45 divided by 50, you would get 0.9. So if you think of these two fractions as decimals, you're being asked to compare 0.85 and 0.9, which of course is the same as 0.90. So you would see that the 17 out of 20 was not quite as high of a score as the 45 out of 50. Now, there's another way to approach this, and it involves finding a common denominator. So 17 out of 20 is hard to compare to 45 out of 50 because their denominators are different. So you think about what the common denominator is. In this case, 20 goes into 100, 50 goes into 100. So 50 was doubled. So if I double the 45, I get 90. And 20 had to be multiplied by 5. So 17 times 5, that one might be one that we'd be wise to work out, is 85. Okay, once the denominators are the same, then again, it should be obvious whether they're equal, and if they're not, which one is bigger. Okay, we're going to move to the next screen, and I want you to look at these two fractions, 3/6 and 4/8. I choose this example because you should know that 3/6 and 4/8 are both equal to 1/2. So that means they should be equal to each other. Well, let's use the common denominator approach. Now you may know that the lowest common denominator here is 24, but I'm going to show you a different method. Let's just multiply the two denominators together. 6 times 8 is 48. When you do that, you're guaranteed to get a common denominator. 48, 48. All right, so 6 was multiplied by 8, and 3 times 8 is 24. Okay, 8 was multiplied by 6, so 4 times 6 is 24. And you see that they're equal. Now, here is the shortcut that most people learn when doing this. You just cross-multiply. You multiply 8 times 3, and that's, this was supposed to be red. Let's undo that. Let's try again. Make this red. There we go. So if you multiply 8 times 3, you get 24. If you multiply 6 times 4, you get 24. If you get the same thing, that means the fractions are equal. The reason being, what you've really done is written them both with the denominator, which is the product of the two original denominators. So to make 3/6 into 48, you have to multiply both of these by 8. Whereas to make 4/8 into 48, you have to multiply both of these by 6. So for convenience, we just go 8 times 3, 24. 6 times 4, 24. Guarantees that they're equal. Now, it would also show you whether two fractions are not equal. For example, if you had 3/8 and 5/9. Well, 9 times 3 is 27, and 8 times 5 is 40, which basically shows you that if you used a common denominator of 8 times 9, 72, these fractions could be rewritten as 27 over 72 and 40 over 72, and 5/9 is the larger. Okay, a proportion is a statement that two fractions are equal. For example, 3/4 equals 6/8. That statement itself is called a proportion. Sometimes you're confronted with a proportion that has a variable, an unknown value. Solving the proportion means finding the value of the variable. So we want to find an x that makes this true. And we're going to use that cross-multiplying technique. So what I'm going to do is consider that if these fractions are equal, then 15 times x has to equal 20 times 9. Or 15x, well, 2 times 9 is 18, so 20 times 9 is 180. And then in order to figure out what you multiply 15 by to get 180, the quickest way of doing that is to divide 180 by 15, which I'm going to try to do this in my head. Let's see. 3, that's 60 over 5, or 12. I don't mind if you plug that into a calculator or do the long division by hand, but in any case, you discover that x is 12. And it's easy enough to check. You just do 9 times 20, you know, is 180. Try 15 times 12, you'll get the same thing, 180. Okay? So this technique always works. Doesn't matter where the variable is, you can solve a proportion this way. So if you had 5 over 13 equals 9 over x, well, you're going to multiply 5 and x, and that should be equal to 9 times 13. And then to get the value of x, you're going to take that, oh, that's a little messy. Let's redo that. What you're going to do is take the 9 times 13, whatever that is, and divide it by 5. I would definitely recommend using a calculator on that. Okay, so your homework. Solve each proportion below using the cross multiplication technique. You can use your calculator, and some of your answers will be decimals. Okay, pause the video if you need to copy these down because it's about to end. See you tomorrow.